In this lesson, we're looking at the shape, center, and spread to describe data distributions. So let's go ahead and get started. When we describe data distributions, we're looking at three things. The shape, that describes the general shape of the distribution. It could be uniform, symmetric, skewed, right or left. We look at the center, that represents the central or the typical value of that data set. And with the center, we use the mean, which is the average or the sum of the values divided by the number of values. And we also use the median, which is the middle value when the values are arranged in order from least to greatest. And the last thing we use is called the spread, that describes how the data values are spread out from the center. And when we're looking at the spread, we look at the range, the interquartile range, and the standard deviation. With the range, that is the difference between the highest and lowest values. The interquartile range, the difference between the first and third quartiles. So if you're not familiar with interquartile range, please see my video on box and whisker plots and dot plots. It goes into further detail about that information. And then we also look at the standard deviation, which is the average of the distances between the individual data values and the mean. When we're describing data by the shape, we look to see if it's skewed left, symmetric, or skewed right. And when we have a dot plot, a histogram, or a box and whisker plot, depending on how that graph looks, the graph is called, or when we describe it by the shape, it is skewed left when the mean is less than the median. So as you can see, from left to right, it's actually smaller on the left hand side, and so that is why it is skewed left. When it is symmetric, that means that the mean and median are congruent, or well, the mean and median are equal, and so it is symmetric. Everything is pretty much in the middle. Skewed to the right, if you notice, it gets lower as it goes to the right, or the graphs here, and that is when the median is less than the mean. We call that skewed to the right. And so this is how we describe data distributions by shape. When we're describing data by the spread, remember we're describing how the data is spread out from the center. So we're not just looking at the center. And we use the range, the interquartile range, and standard deviation. Recall that the range is just the difference between the highest and lowest values, or you're subtracting your minimum and maximum. As an example here, our highest value or our maximum is 16, lowest value is 13. We subtract those two numbers, we get 3. The interquartile range, this may be familiar from box and whisker plot, that's the middle half of the data. So the interquartile range would be right here, and right here you have your lower quartile, and you have your upper quartile right here. And last, we have the standard deviation, that is the average of the distances between the individual data values and the mean. And so the mean would be in the center right here, and you have 1 standard deviation and 2 standard deviations. So this is how, this is what we use to describe data by the spread. Let's take a look at how to describe the center and the spread using the best method. The shape of the distribution can be used to determine the best measures of center, and the spread that should be used to describe that data. And as I mentioned earlier, we have that left skewed, symmetric, and right skewed. And so looking at this chart here, we have the data shape, which is symmetric or skewed. We have it the center, and we have the spread here. And so when the data is symmetric, the data is best described by the mean, and if we're looking at the spread, the data is best described by the standard deviation. When the graph is skewed left or right, and we're looking at the center, the median best describes that data, and if we're looking at the spread, we're looking at the interquartile range. Also, when the data is skewed, it affects the mean more so than the median. Therefore, the median is a better a description for that data for the center, and that's kind of a review from what I just mentioned there. And the inner quarter range is better as the corresponding measure of spread. For our first example here, we want to analyze the mean and the median for the dot plots below, because we're going to describe the data by the center. So remember, if we're looking at the center, we're describing the data by the mean or the median. So for these dot plots, we're given the mean and the median right here. So let's just analyze what we see for each graph. Most of the points for this first graph are to the left, so we can see that right here. It's to the left. The mean is greater than the median. The mean is 3.2 and the median is 2. Therefore, the median is a better description of the center. So if you notice here, the median is 2. The mean would be 3.2, so it would be somewhere over here. All right, and so the median would be a better description of the center because the center is about right here. Okay. Looking at the second one, so I almost forgot. So this graph is skewed to the right because it goes down. So it's skewed, and if we look at the example graph at the bottom. For the second graph, they're about the same, the mean and the median, 8.57 and 8.55. There are more points in the middle. So the mean would be a better description of the center because it's in the middle, and also because this is a symmetric graph here. Everything is in the middle here. And the last graph here, what do we notice about the points? The points are further to the right, right? The median is greater than the mean. So we're looking at the median. Median is 7, the mean is 5.84. Therefore, the median is a better description of the center. So the median is 7 right here. So that would be a better description of the center of this graph here. And so remember, if the graph is skewed, and so keep forgetting, so this graph would be skewed to the left because that graph gets smaller, or is smaller on the left hand side. And so remember, if the graph is skewed left or right, the median is a better description for that graph. If the graph is symmetric, then the mean would be a better description for the graph. For our second example here, we have a list of scores. It says the student scores for Mr. Ahmed's third period algebra test are listed below. And we have a set of scores here, and we also have a corresponding dot plot to match the score. So let's answer these questions. It says, what is the shape of the data distribution? You can see here that most of our dots here in the middle is not skewed left or right, and so that would be a symmetric. What is the best measure of center to use? So part B. The best measure of center would be the mean, because if the graph is symmetric, recall that the best measure is the mean. And what is the best measure of spread to use? So recall, if the graph is symmetric, then we use the standard deviation to measure the spread of the graph. Part C, we want to complete the following by calculating the mean, median, and inner quarter range. We're given the standard deviation. So the mean, remember, that's just the average, so we're going to add all of these numbers up and divide by 14 because there are 14 numbers. So when we add all of these numbers together here, from 60 to 100, we get 1,120, or 1120, and it's a total of 14 numbers, so we divide by 14. So our mean is 80. The median, these numbers are listed in order from least to greatest, and so I'm just going to go from each end here to finally get to my middle point. Alright, and so since I have a total of 14 numbers, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, so this is the upper and lower half. So the average between 80, I have two numbers in the middle. The average of between 80 is just 80, so the median is 80. The inner quarter range, we're going to find the the lower quartile and the upper quartile. So the median of this lower half here, 1, 2, 3, 1, 2, 3. So that would be 70. So we can say that's Q1. And median of the upper half would be 90. So finding the inner quarter range here, excuse my handwriting. So median of lower half is 70, median of upper half is 90. We're just going to subtract those two numbers. 90 minus 70 is 20. So the interquartile range is 20. And part D says, what do you notice about the measure of the center? Why do you think that is? So the measure of the center, they are the same because the distribution is symmetric. So we have 80 and 80 here. The center value, which is the median, will be the same as the average of the mean. This is a symmetric graph here. For example 3 here, I would like for you to pause the video and try this problem. It's similar to the problem we just did, so go ahead and pause the video and try number 3 on your own. Go ahead and check the answers that you have. Hopefully you got them correct. If not, keep the video paused for a little longer to analyze how we got these answers. For our last example here, we're going to look at how an outlier affects the data. Remember, an outlier is a number that is significantly higher or lower than the rest of the data. It lies outside of the rest of the data. So for this example here, it says, after a long day at Disney World, a group of students were asked how many times they each rode Space Mountain. The values are as follows. And first for part A, we want to create a dot plot. So my first number here is 4. And I want to see how many 4s do I have. 1, 2, 3. So I have 4 4s. So I want to put 4 dots above the number 4. Next, I have a 3. I have 1, 2, 3. So I have 3 3s, 3 dots above 3. Next, I have 19. I don't have any more 19, so 1 dot above 19. I have the number 1. Only one person wrote it once. Next, I have 2. 1, 2. I don't see any other 2s, so 2 dots above the 2. And then I have 3 5s left. So 1, 2, 3. Now part B, it says, are there any outliers in the data set above? Explain. So of course, we have this 19 here. It is significantly higher than the rest of these data points. Most students didn't ride Space Mountain anywhere near 19 times. So the outlier causes the mean to be greater than the median. And so we could say that this graph is also skewed to the right. So we've analyzed this data with an outlier. All right, we've reached the end of our lesson. I want to thank you for learning with me. Hopefully you understand data distributions a little better. Some related videos are histograms, dot plots, and box plots, as well as two-way frequency tables. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.